Hello everyone, my name is Jayesh and I am studying at Sri Venkateshwara College of Engineering and I'm bearing the US at 1VE21CS064. I am studying in Computer Science Engineering Department and I'm currently pursuing my second year and I am here to talk about the subject Microcontrollers and Embedded System which has the subject code 21CS34. Let us get into the topic. I am going to be discussing about data processing instructions. Introduction. Data processing instructions. These are the fundamental arithmetic and logical operations of the processor and operate on values in the general purpose register or only one register as a whole. Even multiply and divide may also be considered as special instructions for these data processing instructions. We use data processing instructions to manipulate the data within the registers. And here, data processing instructions are going to have several types or categories. These are the arithmetic instructions, the logical instructions, multiply instructions, comparison instructions, and finally, the move instructions. Most of the data processing instructions uses a barrel shifter in order to pre-process the data of one or more of the operands. Each operation is going to update the different flags in the CPSR. And the different flags in the CPSR are as follows. That is the N, C, Z, and V. N stands for the negative flag, Z is the zero flag, C is the carry flag, and V is going to be the overflow flag. Let us discuss the other following data processing instructions. First one being arithmetic instructions. The arithmetic instructions are mainly going to deal with the addition as well as subtraction of 32-bit both signed as well as the unsigned data values. Syntax is as follows. In the syntax, we have the following instructions. N is the result of the shift operation. RD is going to be the destination register and RN is the specified register. ADC stands for addition with 32-bit values as well as a carry. Add is going to add two 32-bit values. RSD is going to reverse and subtract two 32-bit values, whereas RSC is going to reverse subtract with carry of two 32-bit values. SBC is going to subtract with carry of two 32-bit values, and SUB is going to subtract two 32-bit values, and the result of all of these are going to be stored in N. That is the result of the shift operation. Example, this simple subtract instruction subtracts a values that is going to be stored in register R2 from a value stored in R1, where the result is stored in register R0. R0 is going to have the value of 0, R1 is going to have the value of 2, and R2 is going to have the value of 1. Sub R0, R1, R2, where the value of the result is going to be stored in the register R0, which is 1 as the total. Logical instructions. Logical instructions perform bit-wise logical operations on the two source registers, and the syntax is as follows. Instruction followed by a condition and the register number and specifications, where N is the result of the shift operation, RD is the destination register, and RN is going to be the specified register. And logical bitwise and of two 32-bit values, that is RD is equal to RN and N. Or logical bitwise OR of two 32-bit values. EOR stands for XOR, and this is going to be a logical exclusive OR of two 32-bit values. BIC is going to clear the bit both for and not. That is RD is equal to RN and N. Example. This example is going to show you a logical OR operation between registers R1 and R2, where R0 is going to hold the result. We know that R0 is 0, R1 is 0x0, 20406008, and R2 is equal to 0x10305070. ORR of R0, R1, and R2, where the result is 0x1234567 and 8. Moving on to the next topic. Multiply instruction. The multiply instruction multiplies the content of a pair of registers depending upon the instruction and accumulates the result along with another register. The long multiplies accumulate onto a pair of registers representing a 64-bit value in total. The first result is placed on a destination register or rather a pair of registers. The syntax is as follows, where RS is the source register, RD is the destination register, RN is the specified register. The operations are MFA, that is multiply and accumulate, and the syntax is as follows. MUN stands for multiply, which deals with simple multiplication of two values, which is going to be stored in the specified register. Following these are SMNAN, that is signal multiply accumulate long. SMUNN stands for signed multiply long, and UNNAL stands for unsigned multiply accumulate long. UMUNL stands for unsigned multiply long values. Example. This example here is going to represent the simple multiply instruction that multiplies the register R1 and the register R2 together, and that is going to place the value or the result into register R0. Register R1 is equal to the value 2. Register R2 is also equal to the value 2. Then is going to be replaced to register R0. So here, as you can see, R0 is 0, R1 is 2, and R2 is also equal to 2. MUL of R0, R1, R2, and R0 is equal to R1 and R2. The result is going to be stored in R0, where R0 is equal to 4, that is the output of the multiplication operation, and R1 is 2, as well as R2 is also equal to 2. The next one is going to be the comparison instructions. These instructions are used to compare or rather test a register with a 32-bit value only. These update the CPSR flag bit according to the result, but do not affect the other registers as a whole because it is going to be stored only in one particular register. After the bits have been set, the information can then be used to change the program flow by using conditional execution. And the syntax is as follows, where N, as we all know, is going to be the shift operation result, RD is going to be the destination register, and RN is going to be the specified register. The following operations are CMN, that stands for compare neglected. That is the comparison is going to be completely neglected. CMP stands for compare. TEQ stands for test for quality of two 32-bit values, and TST stands for test bit of a 32-bit value. The example for this is CPSR is equal to so and so, R0 is 4, R9 is equal to 4, and CMP, that is comparison of R0 and R9, where the result of this comparison is still going to be stored in CPSR and the output is going to be generated as follows. Moving on with the next instructions, the move instructions. The move is the simplest ARM instruction and copies N into a destination register RD, where N is a register or immediate value. This instruction is useful for setting the initial value and then transferring these data between the given set of registers. The syntax is as follows. Instruction, the condition given within the parentheses and the following registers with the specified number and specified name, where N is going to be the result of the shift operation, RD is going to be the destination register, and RN is the specified register. The following operations are MOV, that is move. Move a 32-bit value into a register. MVN, you are going to be able to move the not value of the given 32-bit register into the final result. The example of the move instruction are as follows. Here, R5, the register R5 is going to hold the value 5, while the register R7 is going to hold the value 8. Here, we use the function move R7 and R5, where let R7 is equal to R5. So the output of this is R5 is equal to 5 as usual, while the value of R7 is going to change from 8 to 5. This is the use and the function of the move instruction. I hope you understood a lot about the following data which was being explained here, and thank you for watching the video.